In situ remediation is often completed through the application of a substrate into the subsurface using direct push injection. The application is completed by injecting a portion of the required dose at several depths through the target groundwater column. Specialist injection tips can be used to maximize distribution. At Regenesis, we design injectates to remain in the target area and not wash out. The distance the substrate moves from the injection point is known as the radius of influence. The radius of influence is affected by the permeability of the soils into which injection is taking place, with more permeable sands and gravels typically allowing a greater injection distance. The injectate will tend to transport through the same permeable zones along which the contamination is advecting. These layers of high contaminant flow are known as flux zones. Flux zones can be targeted for injection to intercept the mobile contamination and also to address back diffusion of contamination from the surrounding less permeable soils. Accurate targeting of flux zones allows for more effective and lower cost remediation projects. The radius of influence is also affected by the injectate's physical and chemical properties. These include the density and diameter of suspended particles, solubility, viscosity of the substrate, and the volume injected. Pressure can also be increased to assist distribution. However, this can lead to fracturing of the formation, which may have a detrimental effect on emplacement control and overall treatment. As the injectate moves outward, it mixes with the groundwater, allowing the in situ remediation process to begin. Depending on the product used, this could be direct reaction with the contamination, stimulation of biological growth, geochemistry manipulation, or coating of the aquifer with a sorbent. The maximum radius of influence may be considered to be the distance at which the injectate can be observed. However, because of small-scale heterogeneity, it is unlikely that the substrate will have distributed evenly in all directions. At the outside fringe of the injection radius, the amount of active ingredient will be lower than closer to the injection location. The distance a substrate travels will also vary vertically and laterally from the same injection point. In reality, injections are not uniform cylinders. Therefore, if injections are planned using the maximum radius of influence, then areas in between points may receive less treatment. To achieve uniform distribution laterally across the target area, injection locations are designed to create an overlap of each radius of influence. By creating interlocking radii of influence, this ensures all areas receive an effective dose. Looking from above, each injection has a projected radius of influence, which will differ by substrate and volume injected. This radius of influence can be used to design injection spacing for a variety of remediation projects. When creating an injected permeable reactive barrier, if the injection spacing is too wide, underdosing between injection points may result in breakthrough of the contamination. By ensuring the injections interlock, an even dose is created throughout the length of the barrier. When there is a fast groundwater flow or high flux conditions, more rows may be required to create a larger treatment zone along the contaminant flow path. These rows should also overlap and can be offset in a herringbone pattern to further ensure even distribution and effective treatment. If remediation requires application across an entire plume or source area, this is known as a grid of injection points. If the grid is installed where radii of influence are touching and not overlapping, then this can result in areas that may receive no treatment at all. By using a combination of interlocking radii of influence and offset rows, an even and effective distribution can be achieved across the entire target area. For more information, please get in touch or visit regenesis.com.